Edexcel Corpio, complex numbers 4, de Moivre's theorem, powers of complex numbers. We have previously seen how the theorem can be used to write cos theta plus I sine theta to the power n in this very neat simplified form, where the power n was represented as a new argument n theta. Of course, we can now apply this to look at powers of complex numbers where the modulus isn't 1. So if z is r cos theta plus I sine theta and we raise it to the power n, then again we'll see the modulus and the argument change. So the modulus of z to the n is r to the n, as you would probably expect, and the argument of z to the n becomes n theta. So here we want to find cos pi by 5 plus I sine pi by 5 to the power 15. And the beauty of de Moivre's theorem is that it allows us to do this very, very efficiently indeed. So n is 15. Make sure you've got everything in the right place. So we've got the plus sign, so it's in the right form, cos theta plus I sine theta. And notice in this case r is 1, so you don't have to worry about raising r to the power 15. So I can get to the answer by applying the theorem. So the argument will be 15 times what it was originally plus I sine, and don't forget to do both arguments, so that's 15 times pi by 5, which is cos of 3 pi plus I sine of 3 pi, and often the numbers are chosen, the angles are chosen to make them fairly neat to work out. So cos 3 pi is minus 1 and sine 3 pi is 0. So the answer to this is simply minus 1. So just check everything is in the right form. Sometimes you need to check that there is a plus sign there. So everything's in the right form, ready to start. R was 1, we've got the plus sign, cos and sine in the correct place. So when we apply de Moivre's theorem, we just have 15 times the original argument, which was pi by 5. And then of course we can tidy it and work out the answer at the end. So in this second example, make sure we've got everything in the right form. So we've got cos theta plus I sine theta, so that's good. This time we've got an r equals 2, so we must make sure we build that into our solution, and n is 4. So applying the theorem to both the modulus and the argument, we're going to get 2 to the power 4 cos 4 times the original argument plus I sine 4 times the original argument. And then it's just a case of simplifying things as we're going along. 2 to the power 4, we can have 16. We could simplify this angle if we wanted to 2 pi by 3. Of course we could work these out on a calculator as well. 2 pi by 3. Cos of 2 pi by 3 is minus a half plus I, and sine 2 pi by 3 is root 3 over 2. You could leave the answer like that, but it's neater to write it as minus 8 plus 8 root 3I. So in a relatively quick method, we've managed to raise this complex number to the power 4 in 3 or 4 lines of working, and that is the power of de Moivre's theorem. It can make complex number multiplication extremely efficient, particularly when you're dealing with bigger powers. So the key thing again, just make sure everything's in the right form. Watch for the make sure this is in correct modulus argument form before we start. Don't forget to apply the power to the 2 as well as multiplying the argument by 4, and then simplify the answer as much as required. So in the next video we're going to be looking at powers of complex numbers in the form x plus iy.